Hi, sir. This is T. Kushi from my IDE, and my topic for Tech Talk for DA subject is how to design an algorithm. So, let us know about the introduction of an algorithm. The word algorithm comes from the name of a Persian author, Abu Jafar Muhammad ibn Musa Kowarzin, who wrote a textbook on mathematics. This word has taken on a special significance in computer science, where algorithm has come to refer to a method that can be used by a computer for the solution of a problem. This is what makes algorithm different from words such as process, technique, or a method. So before going to know how we'll design an algorithm, let us know its properties. So an algorithm is a finite set of instructions that, if followed, accomplishes a particular task. In addition, all algorithms satisfy the following criteria. The first one is input. There must be zero or more quantities are externally supplied. Output. At least one quantity is produced. Definiteness. Each instruction is clear and unambiguous. Finiteness. If we trace out the instructions of an algorithm, then for all cases, the algorithm terminates after a finite number of steps. Effectiveness. Every instruction must be very basic so that it can be carried out in principle by a person using only pencil and paper. It is not enough that each operation be definite as in criteria 3. It also must be feasible. So completely there are 5 properties of an algorithm. First is input. It can have zero or more inputs, and coming to output, it should have at least one output. So any algorithm will produce at least minimum one output, and maximum it can be n number of outputs depending upon the program and depending upon the algorithm. Next is definiteness. So each algorithm which you're providing, it should be clear and unambiguous. Unambiguous means there should be no kind of confusion in the algorithm which you have written. Next is finiteness. So finiteness is nothing that the algorithm which you have written should end up in finite number of steps. Coming to effectiveness, every instruction must be very basic. So every instruction must be very basic, very clear, simple. Each and every person can understand. So it should be effectively carried out. And it should be feasible. That means affordable. Everybody should afford that algorithm and use it. So now we'll know how to plan an algorithm. So there are various steps that you have to follow. So various steps to plan an algorithm. Following steps must be followed to plan an algorithm. First is devise an algorithm. So creating an algorithm is an art in which may never be fully automated. When we get the problem, we should first analyze the given problem clearly and then write down steps on the paper. So first is devising an algorithm. So writing an algorithm is also not everybody cannot do that, because to write an algorithm you have to see its properties, you have to find its conditions and write it in an effective manner. So the first step is devise an algorithm or design an algorithm. So creating an algorithm is an art in which you may never be successful or you may be successful. Some of them will easily do it, some of them will take time. So whenever we get a problem to write an algorithm, first we have to analyze the problem, and then we have to start writing down the algorithm. So how should you analyze the problem in a very clear and transparent way? If you analyze that problem in that depth, if you go on analyzing and go on searching for that problem, then you can write that algorithm in a very effective manner. Next is you're going to validate the algorithm. So once algorithm is devised or designed, it is necessary to show that it computes the correct answer for all possible legal inputs. This is also known as algorithm validation. So validating the algorithm is nothing but checking the algorithm. So in first step, you're doing all the back-end research, you're doing all the analysis and writing the algorithm. So after writing the algorithm, you have to prove, you have to validate it. You have to prove that this algorithm will give correct answer in any conditions, in all the possible conditions, it is going to give you the correct answer which you need. So that is nothing but validating the algorithm. So what is validating algorithm? Once an algorithm is devised, it is necessary to show that it computes the correct answer for all possible legal inputs. This process is known as algorithm validation. So validation is nothing but checking your algorithm. So once you make any device, you will make one prototype. After checking that only, you will make it in bunch. In the same way, validating algorithm is also being taken. So next, after validating the algorithm, you're going to analyze it. So first step is you have devised you have designed or devised the algorithm, you have validated, checked whether it is working or not. Now, what is this analyzing of algorithm? So analyzing algorithm is nothing but checking time complexities and space complexities of that particular algorithm, because when you're performing a program in systems, it is very necessary to take care of the time complexities and space complexities. And because these days the programs with less time complexity and less space complexity are more efficient and more used. So analyzing the algorithm. As an algorithm is executed, it uses the computer's central processing unit to perform operations and its memory, both immediate and auxiliary memory, to hold the program and data. So analysis of algorithm or performance refers to the task of determining how much computing time and storage of an algorithm is needed. Computing time is nothing but time complexity and storage is nothing but space complexity. So analyzing an algorithm is nothing but checking how much time complexity and space complexity is your algorithm taking. So that if it is taking more time and more space complexity, you have to make some sort of changes and reduce it so that it can be performed in an efficient manner. Next is, after all these three steps are done, now at last you're going to test this program. So testing a program consists of two phases: debugging and performance management. So coming to debugging is the process of executing programs on sample data sets to determine whether results are correct or incorrect. Performance management is the process of executing a correct program on data sets and measuring its time and space complexities. So in testing program, as you have already know, there are two things: debugging and performance management. In debugging is nothing but you will check whether your given output is matching with the computer output or not. You are going to check whether the result is correct or incorrect. In performance management, so you're going to check the time and space complexities of the computed result. So I hope you understood the various steps to plan an algorithm. First is devising an algorithm. Second is validating the algorithm. Third is analyzing the algorithm. Fourth is testing a program. So let us know the techniques of algorithm design. The first one is divide and conquer approach. It is a top-down approach. The algorithms which follow the divide and conquer technique involves three steps. The first one is divide the original problem into set of subproblems. Solve every subproblem individually, that is recursively, and combine the solutions of the subproblems into a solution of the whole original problem. So this is the one of the technique, that is divide and conquer technique. In this, you will take an array and you will divide into subproblems, and these subproblems are solved individually, and at the end they are again combined into a original problem. Next is greedy technique. Greedy technique means it is used to solve the optimization problem. So greedy means, as you all know, the word itself says more profits within less amount of time. So greedy method is used to solve the optimization problem, and optimization problem is one in which we are given a set of input values which are required either to be maximized or minimized, that is constraints or conditions. Greedy algorithm always makes the choice looks best at the moment to optimize a given objective. The greedy algorithm does not always guarantee the optimal solution. However, it generally produces a solution that is very close in value to the optimal solution. Next is dynamic programming. So dynamic programming is a bottom-up approach. As you have seen, divide and conquer is top-to-bottom approach. Dynamic programming is bottom-up approach. We solve all possible small problems and then combine them up to obtain solutions for bigger problems. This is particularly helpful when the number of copying subproblems is exponentially large. Dynamic programming is frequently related to optimization problems. So whenever there are optimization problems, in such cases, you'll use dynamic programming. Branch and bound. In branch and bound algorithm, a given subproblem which cannot be bounded has to be divided into at least two new restricted subproblems. Branch and bound algorithms are methods for global optimization in a non-convex problems. So branch and bound algorithms can be slow. However, in the worst case, they require effort that grows exponentially with problem size. But in some cases, we are lucky and the method coverage with much less effort. Next is randomized algorithms. A randomized algorithm is defined as an algorithm that is allowed to access a source of independent, unbiased random bits and it is then allowed to use these random bits to influence the other computer. Random bits are taken, chosen, and executed. Next is backtracking algorithm. As you all know, backtracking we have seen in depth first search in data structures. So backtracking algorithm tries each possibility until they find the right one. It is a depth first search of the set of possible solutions. During the search, it is an alternative, then backtrack to choose the point, the place which presented different alternatives, and tries the next alternative. Next, coming to randomized algorithm, again you will have, let us see the examples of randomized algorithm. A randomized algorithm uses a random number at least once during the conception or computation to make a decision. So first example is in Quicksort, you use random number to choose a pivot value, and trying to factor a large number by choosing a random number as possible divisors. So what are the algorithm designing techniques? First is divide and conquer method. Next is greedy technique. Next is dynamic programming. Next is branch and bond. Random sized algorithms. For random sized algorithm, the examples are quicksort and all, and backtracking method, that is depth first search. So what are the specifications of an algorithm? So an algorithm comment lines begins with double backslashes, and continues until the end of the line. Blocks are indicated within matching braces. An identifier begins with a letter. The data types of variables are not explicitly declared. Compound data types can be found with records. Here is an example, node is equal to record. Here linked is a pointer to the record type node. Individual data items of a record can be accessed with the help of the arrow. Input and output are done using the instructions read and write. There is only one type of procedure, algorithm. The heading takes the form. So you will write the algorithm starting name as algorithm, name of the algorithm, and parameters list. So let us see the example. Algorithm max of A, comma n. So we are going to write the algorithm to find the maximum value. So A is the size of an array. So result is equal to A of 1. For I is equal to 2 to n, do. If A of I is greater than the result, then result is equal to A of I, return result. So this is one of the example to write an algorithm. So let us once again see what are the things required. So generally in algorithms, you write comments in comment lines in with two backslashes, and algorithm is written within curly braces. And an identifier begins with a letter. And you will input and output are done using the instructions read and write. And the procedure to write the algorithm heading is algorithm, name of the algorithm, and parameters list. So let us see some of the examples of algorithms. So the first example is to find the sum. So algorithm sum A comma n. A is the array. So sum will initiate with 0 for I is equal to 0 to n. Sum s is equal to s plus A of I. Close the bracket and return sum. So this is an algorithm example for summation of elements. Next is matrix multiplication. So algorithm multiply. So you're going to take three matrices A, B, C, and MNP are things. So for I is equal to 1 to M, for J is equal to 1 to N, and for K is equal to 1 to P. Do C of I, J is equal to A of I, K star, B of KJ. So M and P are the matrices, number of rows and columns in that way. So here this is matrix multiplication algorithm. So you'll have algorithms in two types of algorithms: recursive algorithms and iterative algorithms. The algorithms which we have seen for summation and matrix multiplication, these are iterative algorithms. Now let us see recursive algorithms. So we are going to see recursive algorithm for summation. Algorithm R sum of A comma n. If n is less than or equal to 0, then return 0.0. Else return R of sum of A comma n minus 1 plus A of n. This is for summation of elements in recursive way. And for stacks, let us see the algorithm. Algorithm add item. If top is greater than or equal to n minus 1, then write stack is full, return false. Else top is equal to top plus 1, stack of top is equal to item, return true. So these are the examples of recursive algorithms. So what are the advantages of algorithms? Effective communication, easy debugging, easy and efficient coding, independent of programming language. So effective communication, since it is written in a natural language like English, it becomes easy to understand the step-by-step of solution to any particular problem. Easy debugging. A well-designed algorithm facilitates easy debugging to detect the logical errors that occurred inside the problem. Easy and efficient coding. An algorithm is nothing but a blueprint of a program that helps to develop a program. Independent of programming language. Since it is a language independent, it can be easily coded by incorporating any high-level language. So thank you. I hope you have understood how to design an algorithm. What are the types of algorithms and what is iterative algorithm, recursive algorithm. And I hope you also understood about the advantages of usage of algorithms. Thank you so much.